Okay, let's look at this example of a contingency table. Okay, so diagnostic tests of medical conditions have several results. The test result can be positive or negative, whether or not a patient has the condition, and so the positive indicates a patient has the condition. Consider a random sample of 210 patients, some of whom have a medical condition and some of whom do not. Results of a new diagnostic test for the condition are shown. Okay, so in this is called a contingency table that shows us the results. And it does assume the samples represent the entire population. So we want to compute the following probabilities. So this table is telling us that there were 110 people who had a positive test result and had the condition present. There were 30 people that had the positive test result but didn't have the condition. Are you with me? Okay, so the probability that the test result was positive, we're trying to find the probability of a positive test result. So we want to look at the row that had a positive test result to find how many people. So I look at the total row. There were 140 people that had a positive test result out of a total of 210 people. So our probability is 140 over 210. Make sense? Okay. Oops, sorry about that. Just trying to erase my little arrows here. Okay, so let's look at this next one here. The probability that the test is negative given the condition is present. So we're looking for the probability of a negative test result given, remember we write that as given, the condition is present. Okay, so anytime you're doing a conditional probability, you only want to look at that row or column. So I look for, is it a row or column that has the condition present? Here's condition present. That's a column, right? So that means I'm only looking at these numbers when I calculate this probability. So out of those numbers, I'm looking for the number that had a negative test result. You're right, that's 20. So it's 20 out of 130 patients. And that's my probability. That's my conditional probability. So conditional probabilities, again, you look at the word that's given and see if it's a column or a row. Okay? Okay, let's look at this next one. Let's find the probability that the condition is absent, probability that it's absent, given the test is negative. Okay. What I'm given is that the test is negative. Where do I find that in my contingency table? Right here, test is negative. Well, that's a row now, right? So I'm only looking at the numbers in that row when I find my conditional probability, nothing else. So in that row, how many were absent? They did not have the condition. It looks like 50, right? So 50 people did not have the condition out of the 70 people that had a negative test result. Make sense? Okay. Let's see if I can erase that. Now let's look at part D, the probability that the test is positive given the condition is absent. So this is a little bit different than the one before. Now the given part is absent. So that's a column this time, so I'm only looking at this column when I calculate my probability. So in that column, of the people that did not have the condition, how many had a positive test result? It looks like 30 out of 80 that were absent. Make sense? Okay. All right, this next one is find the probability that the condition is present and the test is positive. Okay, this is no longer a conditional. This is a multiplication rule. Now, the trick with contingency tables, when we're dealing with and, we only have to find where they intersect. Okay, so the probability that how many people had the condition's present, right? And positive. Where do those intersect? Right here. So it's 110 people out of our total sample of 210. So the only time our sample sizes change is when we're dealing with conditional, the givens. Okay, so when we have these conditionals, that's when we have a smaller sample size. Make sense? If we're dealing with and, it's no longer dealing with the conditional, and we're dealing with the total population. Okay? Okay, let's look at this next one here. We have two more. We want the probability that the condition is present and the test is negative. So I'm going to let you guys calculate that one on your own. Let's do this last one, part G. What is the probability that the condition is absent or the test is negative? Now, with the or, we do have to use our formula. So if you remember, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So in this case, this would be the probability that it's absent plus the probability that it's negative minus the probability of absent and negative in our formula. Okay, so the probability that they're absent, okay, absent, there were 80 absent out of 210. So we have 80 over 210 plus probability that's negative. Let's look at the negative. Negatives right here. So all the negatives, so that's 140 out of 210. Do you see that? Oops. 140 out of 210. Now we need to subtract the probability that's absent and negative. So the number of people that had the test result absent and negative, so we look for absent and negative, it looks like 50 out of our 210. Remember, the and is always out of the 210. So anytime you have the or with the contingency table, we do have to use the formula. So we have 80 plus 140 minus 50 all over 210. So I think that's 170, right? Over 210. Now I left both of these as all of these as fractions. You can change them to decimals, and I'm not sure how the Newton will take it if it takes it as fractions or decimals.